Moving into lesson 6, we are going to look at multiplying rational numbers. Remember, rational numbers are whole numbers, they're fractions, there's decimals, there's negative numbers. So we're going to take a look at how to multiply these together. So for our first example here, Vera is given 3 fractions. She wants to find the 2 fractions that have the greatest product. Which 2 fractions does Vera multiply together to get the greatest product? Remember, a product is the answer to your multiplication problem. So we have these 3 numbers that we need to look at and try to pair together. So if I take this first fraction and multiply it by the second fraction, I have a positive times a negative. That is going to result in a negative answer. And then if I do that first fraction and multiply it by the last fraction, again, I have a positive times a negative, and that is going to result in a negative answer. So we're going to see if maybe if I multiply these other 2 together, will I get a positive answer? Well, if I multiply a negative times a negative, I will get a positive answer. So which 2 fractions can she multiply together to get the greatest product? It's these 2, because 2 negatives multiplied together will give a positive answer. Rational numbers, here is the definition. I just talked about that at the beginning. So anything that can be written as a quotient of 2 integers. So anything that we can turn into a fraction is a rational number. So for this next example, we're going to practice multiplying some numbers together. So example part A here is 2 times negative 9/4. Well, in order to do this, you're going to have to make the number 2 into a fraction. So to make a whole number into a fraction, we just put a 1 under it. And then we're going to multiply by negative 9/4. Now, you can reduce one of 2 ways. You can reduce before you multiply, or you can reduce after you multiply. I highly suggest reducing before you multiply when you're working with fractions, because it leaves you with smaller numbers in the end, and they're easier to work with. So the way we reduce before we multiply is we look at numbers on an angle. I have 2 and 4, and they're both even numbers, so I know I can cut those in half. So half of 2 is 1, and half of 4 is 2. And then I look in the other direction, 1 and 9. I can only divide those both by 1, and that's not going to change their value any, so we're going to leave those alone. So now on the top, I have 1 times negative 9, which is going to give us negative 9. And at the bottom, I have 1 times 2, which is going to give us 2. So we're going to keep that negative sign. This is an improper fraction because 9 is larger than 2. So how many 2's are in 9? Well, that's 4, so that takes us to 8. We would need to get to 9, so we have 1 left over, and our denominator is 2. So our answer to this question is negative 4 1/2. For part B, we have 2 fractions here, 2/3 times negative 9/4. So again, I'm going to look to see if I can reduce before I multiply. So on an angle, I have 2 and 4, so I can cut those in half. And then on the other angle, I have 3 and 9, or negative 9. And I can divide both of those numbers by a 3. So 3 divided by 3 is 1, and 9 divided by 3 is 3. Don't forget about that negative sign that's still there. Now I can multiply across the top. And 1 times negative 3 would be negative 3. And across the bottom, 1 times 2 would be 2. And then the top number is larger than the bottom number, so we're going to have to make this proper. Carry over our negative sign. 2 goes into 3 one time with 1 left over, and 2 is our denominator. So our answer is negative 1/2. Now, I want to show you what this would look like if we didn't reduce first. We would have negative 18/12. And then we would have to reduce 18 and 12. I know I can divide both of those by 2. They're both even numbers, so if I cut them in half, I would have negative 9 and 6. And then 9 and 6 have a 3 in common, so divide everything by 3. I have negative 3 and 2, and then I can turn that into the negative 1 1/2. that I got in the first place. So, like I said before, I highly suggest reducing beforehand. However, you're still going to get the right answer if you reduce later. All right, for part C, we have negative 1 2/3 times negative 1/2. So in order to multiply this, I need to make that negative 1 2/3 into an improper fraction. So we start at the denominator and we go to the left and we're going to multiply. So 3 times negative 1 is negative 3. And then we're going to go around and add the numerator. So negative 3 plus 2 is going to give us 5. So negative 5 over 3 times negative 1 over 2. And looking on an angle, I have a 5 and a 2. Those don't have anything in common, and 3 and negative 1 don't have anything in common, so I can't reduce now. A negative times a negative is going to be a positive, and 5 times 1 is 5. And then on the bottom, 3 times 2 is 6. So 5, 6 can't reduce, so that is our final answer. And then for decimals, we simply multiply like this would be 31 times 42. And 2 times 1 is 2. 2 times 3 is 6. Put our place value over, so we move over to our tens place. 4 times 1 is 4. And 4 times 3 is 12. And then we add those together. 2 plus 0 is 2, 6 plus 4 is 10, carry the 1, that would be a 3, and that would be a 1. Now for our decimal, if we go back to our original problem, we have 1 decimal place here and 1 decimal place here, so that's a total of 2 decimal places. So we are going to move from the back of the number back 2 places and put our decimal there. So our answer here is 13 2/2, and a negative times a positive is going to be a negative. And for our last example, the temperature at noon is 0 degrees Celsius. The temperature changes by negative 3/2 of a degree Celsius every hour for 4 hours. Write an expression to represent this situation, and then what is the temperature at 4 p.m.? So this question has 2 parts. The first one says, write an expression. So I know it's going down 3/2 every hour for 4 hours. So it's going to do this 4 times. So I'm going to multiply that number by 4. So there's my expression. Then it says, what is the temperature at 4 p.m.? So here is our second question we're actually going to have to solve. So negative 3 over 2, and we're going to change that 4 into a fraction, so we're going to put a 1 underneath of it. And then we're going to look to see if we can reduce. 3 and 1, there's nothing, but 2 and 4 have a 2 in common, so I'm going to cut everything in half. And then negative 3 times 2 is negative 6, and 1 times 1 is 1, so that would simplify to be negative 6 degrees Celsius, that the temperature had changed. And it says, what is the temperature at 4 p.m.? Well, it was at 0 degrees, and 4 hours later, it had gone down 6. So from 0 and then moving down 6, we're going to be at the negative 6 degrees Celsius.